In this lecture, our workers will be able to resume a building that's been paused due to the death of another worker. Let's go. We've already talked about this a little bit, that we want to change the interaction paradigm between the worker and the building. If we take our behavior tree here, if we right-click on a building that's in progress and does not have another worker building it, we should still issue our build building command. That worker should still move to the target location, and they should start building that building. That's really what we're going to be implementing in this lecture. Just so we could see the building progress was being set, in the previous lecture, we did in the worker base building that start building. This isn't the right interaction though. Based on what we just saw in the behavior tree, we want the build building action to call this instead of it happening as soon as we issue the command to the worker. So let's remove this line and say if instance.tryGetComponentOutBaseBuilding returns false, we can use the discard naming here. We don't really need the base building reference. In this case, we want to do our error logging still, because we can't build a building that doesn't exist. We're going to want to also add an entry point to resume building. So that should go in our iBuilding builder. Any unit that can build something should also be able to resume. Let's add a public void resume building to our iBuilding builder, and it should accept a base building. That's going to be the building that we want to resume. And back over on worker, now it's going to complain at us that we don't have that function implemented. So right below build, let's do public void resume building that accepts the base building. And we're going to come back to this. This is like the lowest level implementation. We're going to go up the chain and make sure everything works before we get into that. The next step up would be our build building command. In here right now, we are just calling build, but it's possible that we want to call resume, which means our can handle needs to also consider, did we hit a building with a right click? And if so, we want to resume in that case. So how do you think we should handle can handle? If context commandable is not an iBuilding builder, we want to return false. We know it's not going to work. Now, if the context hit collider is not null, then we want to check some stuff because it could be that we can handle this case, right? In which cases can we handle it? Let's return if the context.hit.collider.tryGetComponentOutBaseBuilding. And if the building, that's our building SO, equals to the building's building SO, so it's the same building, but we can't access building SO because it's private. So in base building, we've got a private building SO. Let's move that up. Convert it to a field serialized field, make it public, give it a public get and a private set, and rename it to be capital so it follows our naming convention. Then we can come back to build building command, and now that looks okay. So if it's a building and it is the same type of building as this, maybe, but we only want to do that if the building state is either paused or destroyed. We'll check and then in parentheses, building progress state is equal to paused, or building progress state is equal to destroyed. Because if it's completed, we don't care about it, right? We'll just move to that location instead. Let's just format that so we can see it all on screen. And if the context hit collider is null, then we'll say, yeah, okay, we can handle it. No problem. We don't need to worry about all this other stuff, which means we also need to change something in handle. What do you think we need to do here? Well, we still want to build if we didn't click on a building. So how can we check that? We'll check if the context hit collider is not null and the context hit collider try get component out base building. We'll do something there, resume the building. But in the else case, we'll keep doing the builder.build. In that top if, we can just do builder.resume building. Now we need to go one step up. So when we right click, we can see our build building commands. So that's on our player input. In our player input, when we handle right click, down here is where we are finding them. And we're just picking based on the abstract unit's currently available commands, which works okay, right? It so far has been fine. But now we want to right click and potentially build units which are hidden in a submenu. So what we want to do is get the available commands for this worker or for this unit, whatever it is, and find out if we should use any of those ones in the hidden menus. So why don't we say, instead of just grabbing the available commands, say get available commands and provide the abstract unit that we're talking about. Let's define that as a private list of type action base, get available commands that accepts an abstract unit. What we're going to do here is one way to dynamically get these. We could also just dump all the available commands into the player input. I find that's a little bit more tedious to maintain as you start growing more and more commands. It's easy to miss it here. So it's nice to be able to grab them automatically off from our units. Before we get too deep into this, take a second and think about how might we get all the available commands. The first thing we need to do is find out, do we have any override commands? Because those are the only ones that we have that have some hidden commands, right? Let's define an array of override commands, and we're going to use link to make this much more condensed than if we had to do it without link. Set that equal to unit available commands dot where, which comes from the system link. We'll provide a function here that will be executed for each item in the array. Commands dot arrow command is override commands command. That'll give us only the commands that are override commands. Then we can cast them safely to that type and return it as an array with .toArray. Then let's define a list of action base. All available commands equals a new list. Then we're going to go over all of our override commands for each override commands, override command in override commands. That's a lot of commands. And we're going to do all available commands.add range override command.commands.where the command is not an override commands command. This is tricky because in our show buildings action, which is an override commands command, it also has reset commands action, which is also an override commands command. So we don't want to show reset commands action in this all available commands, because these are both like dummy actions. They don't add value. If we right click, it's just going to look like our worker does nothing. So that's why it's important to filter those out like this. Now we want to take all the unit available commands, but we want to filter some of these out as well. We don't want any of those override commands command to show up for the same reason as before. Let's do all available commands.add range unit.available commands. And we want to do where command is not override commands command for the same reason as before. Then we can just return all available commands. This should now give us all of the available commands that are not override commands, and we will prioritize those hidden commands like the building commands. There's one more thing we need to take a look at, and that's down here in activate action. We need to remove the can handle check, or it causes some weird behavior. If you want to see what happens exactly, just leave it in there and start right clicking. You'll see why we need to remove it. Now we're almost there. Back to the worker. We're going to call resume building when we right clicked on that building. And this lecture's challenge is to implement that resume building function to set up the Blackboard in any other state required to make the worker continue building that building. So pause the video, implement this resume building, and I'll see you back here in just a minute. All right, welcome back. We're going to want to do almost an identical thing to what we did in build, just with very small differences. Primarily, we need to set up the Blackboard. So that's a graph agent, set variable value. We want to set the target location to where the building is, building transform position. We hinted at this earlier that we want to set the building under construction to be this building. We're relying on the building SO to be set. So we need to set building SO to the building.building.SO. And the tricky one here, we want to set the ghost to be null. There is no ghost. And remember, we will destroy the ghost if it's set. When setting a variable value to a null value, since we can't infer the type, we have to specifically specify that this ghost is a game object. Then we want to set the command to be unitcommands.buildBuilding. We do want to override our commands, set override commands to a new action base array of only one command, cancel building command. And we want to, again, raise our unit selected event so our UI refreshes. That's all we were looking for this challenge. And if you got on your own, congratulations. Let's come back into Unity and open up our worker behavior tree. We can't just click play because we'll get some errors. This has changed a little bit over time, where the destroy node will now fail if the value is null. It used to just silently continue. What we're going to do now is conditionally destroy the ghost. So let's move the build building node up, delete the edge going into our sequence here, connect build building just into the move to target location node, drag down from that node into a new one. We'll go to flow, conditional branch, just like what we did over here with the supply amount held. Assign a condition, variable conditions, variable comparison to the ghost. And if the ghost is not equal to null, that's true, we'll destroy it, and then come to set navmesh agent status to false. And in the false case, we'll just go straight there. Tells us we need to merge these, wait for any, confirm that, reorganize our graph, get out of there and click play. Select a worker. This is worker 6, remember. We'll let them build a little bit until we can really see the building. We'll delete them so they're dead. take another worker and we want to right click and they should come resume this building. They run over there. They got the building. The building did not change and it just keeps coming up from where it was before. That's awesome. A couple of important notes about this implementation before we get out of here. The way we're choosing our available commands are the same. They're going to be in the order that they appear here. So they're going to take the priority order of gather, move, stop, and show buildings we're excluding. And in show buildings action, it's going to try to do these, again, all in the right order, which shouldn't really matter the order on the show buildings action, because if we're clicking, we're only going to be clicking on one building. So only one of these will work. And we still have a bunch of cool things to implement for our building. When you're ready to move on to those, I'll see you on the next lecture.